Now, the downside of wind and solar is that they can be erratic. Wind fluctuates widely. It can be forecast up to a day or so ahead, but not much more than that. Though offshore winds are more stable and predictable. And solar power, of course, varies over the course of the day. Though solar power is very predictable, and it has the nice property that it's at its strongest in the middle of the day, which is when the demand for electricity is highest. So there's something quite good about solar power there. This shows you what I mean when I say that it fluctuates a lot. This is the output, the aggregate output of all wind power stations in the United Kingdom over 1 quarter. And you can see it fluctuates wildly from almost 2 gigawatts down to almost 0 within a day or so. Wind can drop away. You can have a 25-mile-an-hour wind now, and you have 0 wind in 4 or 5 hours from now. So integrating something which is as variable as that into the grid can be quite a challenge for the people who manage the grid. And that's something we have to talk about. This is the output of solar power in California. This is 1 day from March of last year. The yellow curve here is the output of solar power stations in California. As you can see, it's very predictable. It starts at 6 a.m., finishes at 6:30 p.m., and reaches a peak in the middle of the day, which is when the demand for power is highest. So that's actually quite nice. The other thing you might notice from this diagram is that this blue line here is wind. Wind is lowest in the daytime when solar is high, and highest at nighttime when solar is low. So wind and solar do tend to complement each other in many geographies, with wind being stronger at night and solar being stronger during the day. So you put the two of them together, you get less fluctuation in aggregate than either on its own.